Okay, diagram shows a sketch of y equals x squared and the normal to the curve at point 1, 1. So that's 1, 1 there, that's a normal. So obviously I'm going to have to work out the gradient for that, work out the normal, and use differentiation to find the equation normal, and I've got to verify that b cuts here. Okay, so first thing I want to do is do dy by dx, and that equals, we've got x squared, that would differentiate to 2x, and when x equals 1, the gradient of the tangent equals 2. 1 times 2, therefore gradient of normal is minus a half. And so I've got y equals minus a half x plus c, and I want to find c, so I'm going to sub in, and I will sub in 1, 1. As always, that's the x, and that's the y, although when they're both the same, it really doesn't matter. So y is 1, so 1 equals minus a half times 1, which is minus a half, plus c. So c will equal 3 over 2. So I get y equals minus a half x plus 3 over 2. And you can actually see it's likely to be right. That's plus 3 over 2. Yeah, it's bigger than 1. And the gradient does go down. So it's minus a half. Verify where it cuts the curve. So now what I need to do, I need to solve when the curve cuts a line, and therefore I've got this and y equals x squared, and therefore put them together, y equals x squared, so that's x squared, so that gives me x squared minus a half x plus 3 over 2, no, x squared equals minus a half x. Yeah, like so. Times everything through by 2, so 2x squared equals minus x plus 3, and get it all onto one side, so 2x squared plus x minus 3 equals 0. That will factorise, and actually we can be clever because we know one of the solutions is got to be 1, so x is 1, so x minus 1 is going to have to be one of the factors, and that's going to have to be plus 3. Now work around it, 2x squared minus 2x plus 3x, yes, plus x minus 3, yep. So either the first one equals 0 or the second one does, so either x equals minus 3 over 2 or x equals 1. We've already got that one, so x is minus 3 over 2, and that means that y will be, this is x squared, y will be, let's put that sub in y equals x squared, y will equal 9 over 4. And so our point is minus 3 over 2, 9 over 4. That has been verified. So the good thing about that now is I know that point there is minus 3 over 2, like coordinate. So find this region. Find it by working out the area of the trapezium and then subtracting the area underneath the curve y equals x squared. What I'm going to do is one just big integral. So the area equals going from minus 3 over 2 to 1. It's got to be underneath the curve, and the curve is minus half x plus 3 over 2. So that's a bit, all the bits there, but indeed the area of the trapezium, and now I've got to take away the area underneath the curve, so that'll be minus whatever the equation is, that'll be x squared dx. Now I just need to integrate everything, so that's going to be increasing the power it's got to get minus a half, so that's going to be minus a quarter of x squared plus 3 over 2 of x, and this will be x cubed with 3, so it'll be 1/3, that's been minus 1/3 of x cubed between 1 and negative 3 over 2. Put those things in. Lovely, putting in 1, that's just minus a quarter plus 3 over 2 minus 1/3, and then minus, putting all this, that's a minus a quarter times by that squared will be 9 over 4, it's positive now, plus 3 over 2 times by negative 3 over 2, and then minus 1/3 times by negative 27 over 8. And that, put that into calculator, comes to 125/48, or indeed it's exactly the same as 2 and 29/48. And it's done.